Hello and welcome everyone to SQL Friday number 73. And our start today is, I'm going to say Hugo Kornelis. I know that's not the way to pronounce your name, Hugo, but it's a Dutch sound that I just can't make. So anyway, welcome here. I met Hugo first time in SQL Nexus in Copenhagen, and he was talking about normalization, which is I really liked the content and I really liked Hugo's presentation style. So I'm really happy that you're on SQL Friday. I'll leave it up to you to make a proper introduction of your session and of yourself. Welcome, Hugo. By the way, people, if you have questions, type them in the chat and I will interrupt Hugo. Don't unmute yourself. Thank you.
Thanks for the introduction, Magnus. It's very interesting that your first impression of me was a normalization session, because I think 99% of my content is related to performance and mostly execution plans. So today we're going to talk about execution plans. In the session, here's the execution plan. And now what? It helps to have the correct focus, then this works. Indeed, the correct pronunciation of my name is slightly different, Hugo Kornelis, but I listen to Hugo, to Hugo, or even to Hey You, and some other stuff that sometimes gets thrown my way, but I prefer not to say in public. My name is Hugo Kornelis. I make SQLServerFast.com, and SQLServerFast.com is the website where I build a lot of stuff, like for instance the execution plan reference, a reference material where you can check things for execution plans. If you encounter an operator or a property you don't know, chances are it's not finished yet, but chances are most of the common stuff is there already. So if you encounter something and you're unsure what it means, check it out on the execution plan reference. A lot of information is there available for free. I also have a long series, I think 18, 20 videos now in 3 parts. Planned is a total of 14 parts. So we'll be working on that for a long time. That is actual execution plan training, where I take you from the start to star. The first part of 7 or 8 videos is available for free. The rest is not available for free. I think it's very affordable, but it's even more affordable if you buy it between now and March 15 and use the code SQL Friday. I think it's case sensitive, so make sure that you use the proper casing. And then you have a 10% discount on an already very affordable, in my opinion, offer. Use it or don't use it, that's up to you. I have a lot of other stuff on SQLServerFast.com, like my blog, and very important, I have a resources section there. So if you go to SQLServerFast.com, you can go to the menu, choose other presentations, and then presentation resources. You will find a list of sessions. Why am I expanding on this? Because you might want to have access to the demo code I'm going to show you today. Slide deck is completely useless. It's just the intro slides and the end slide because it's a demo only session. But the demo code can be very interesting. It's there. If you want to see the slide deck or the demo code of my other presentations, it's there too. All available for free. Just download it and use it as you see fit. I do a lot of other stuff as well, but you don't really care about that. The only thing you care about is my email and my Twitter. And why do you care about that? Because you might have questions. As Magnus said, if you have questions during the presentation, type them in chat. He will read them to me. I will answer them. Try to answer them. But if you have questions later that are relevant to the content of what I do for the community, mail me or tweet me and I will try to get back to you. So what is this session about? This session is about a common problem I hear when people are learning execution plans. Very often the teacher, and that includes me and most of my training material, has this habit of, hey, I'm going to teach you something. I'm going to teach you a specific thing about execution plans, and then we present an example that is very simplified, very simple, very clean, so that you can quickly and easily focus on the one thing we try to explain, and then we give you a lot of information about that simple thing on your screen. And you're listening to it and paying attention, and you're like, aha, I get it. I have learned something. I now understand execution plans. And then the next day you return to your office. A coworker says, hey, you had this course on execution plans yesterday. You are smart now. You can help me because I have this performance problem. Here's the execution plan. And then you are like, that's not what I saw in the classroom yesterday. I have no clue where to start with this big steaming hype. I can't do English anymore, but this big steaming pile of whatever this is called. And you have no clue how to tackle this because this is not a clean and simple example. So what I try to do in this session is to bridge the gap between those clean classroom examples and those incredibly messy execution plans that reality throws in your face. What I'm going to do is run you through three cases. Damn, I really can't speak anymore. That's bad for a speaker, not being able to speak. I'm going to run you through three cases based on realistic scenarios, not clean classroom examples, but realistic cases you might run into in your work. They are toned down a bit. It's not complete production complexity because I only have 1 hour. It's medium complexity. So it's somewhere in between those clean classroom examples and the messy reality, trying to bridge the gap. So we're going to give you three cases, and I'm going to walk you through how you can use an execution plan to pinpoint a problem, find the root cause, fix it, and then verify whether your fix actually helped. The first example I'm going to show you is one of excessive I/O. And now it's time to jump out of the presentation and into the demo. Let's first start the setup. Contents of this is not really important. You can read the comments later if you download it. I just want to have it running and started so that everyone is there. And when the setup is no longer, there we are, it's completed. Now we can go to the sample database. And the first problem I want to talk about is excessive I/O. So maybe you are a DBA and you have identified a problem with excessive I/O caused by a store procedure. Or maybe you are a developer and your production DBA comes to your desk or sends you a ticket saying, this store procedure causes way too much I/O. It's clogging up the system. You need to tune it. So the problem query is this store procedure sales by regions. And if you just execute it to get a feel for what it does, you will see that in this case, execution is quite fast. Well, we weren't asked to fix the speed, so that's not even really that important. But I do like, when possible, when it's not a 2-hour procedure, to just execute it first, look at the results, to get a first feel for what the store procedure does. So it creates a report with color, number of products, number of orders. Well, you see the data on your screen. Now, it's a store procedure, so I need to know what is going on in the store procedure, which means I'm going to connect to the correct server, find the right database, go to the store procedures tab, and I always forget the name, sales by regions. There we have it. Now, I'm going to be lazy and spend a lot of time to explain how lazy I am, because a lot of people will say, I'm going to script the store procedure as create or alter to new. That's a lot of mouse clicks. I always just right click and then modify. Not because I'm going to modify it, but because this does the same thing as script store procedure as alter to new query window. So that's 1 click instead of 3, which saves me a lot of time unless I'm going to explain it during a presentation. Then it takes me a lot of time, but it's going to save you some time later. So I'm not actually going to modify it. I would modify it if I execute it here, but I'm not going to do that. I'm just going to look. We have the text of the store procedure and we have a comment. You may not know this, but in production, I'm always happy when I see a comment because a lot of production code is simply uncommented. I see a comment here. That makes me happy. And then I see all these weird letter combinations and I'm no longer happy. And yeah, this probably made sense to someone when they typed it. But I need to decode this now. But the start is simple. We need to join sales order header to address, then to state province, then to sales territory, then to country region. And apparently we need to do that 2 times. Okay. We also need to join sales order header to salesperson, sales territory. Okay. And then we will first do okay. So all these letters refers back to all these table names here. So SP is then probably salesperson. Yeah, SP to ST to CR, that's salesperson to sales territory to country region. And ASP ST CR, that then has to be addressed to, yeah, okay. Now we get what these letters mean. We started to decipher the comments. Sometimes comments are even harder to read than code. And apparently, whoever wrote this store procedure said, I'm going to store the result in table variables to make the join to salesperson more efficient. Is that true? Is that not true? I don't know. Someone claims it may have been tested, may have not been tested. Sometimes people have picked up something and think it's true, but never verify it. But that's what the person writing this said. So, and then there's first a join of sales territory to country region. So that's this join that's used in these 2. Okay. So we have a table variable sales territory to country region name. And here we have a select from yeah, that's the join from sales territory to country region. So that data is stored in a table variable. And then that sales territory to country region name is used in the next step to get salesperson to sales territory to country region. Well, that makes sense to reuse that there. And then we also need address to state province to sales territory to country. That's weird. We could have reused that same table variable here, but we didn't. So I'm not sure what was going on in the mind of who wrote this, but they were not very consistent. It happens in production code. You will run into these weird things. And there may be a reason for this. It may simply be a simple, stupid mistake. We don't know. I'm not going to fix anything at this point. The reason I'm not going to, my fingers are itching to do something about the bad comment, to do something about this weirdness, to verify the assumption that the table variables save time. I'm not going to do that because I'm paid by my boss to do a specific job, and that job is to reduce the IOs. A bad comment doesn't cause IOs. This might or might not cause IOs. I don't know, but I first need to make sure that I'm doing the right thing. So I'm just going to look and observe and record all this. Now we get the actual query. There's a comment here. Let's do the actual query. So here, well, we saw the results. There was a color, and then we had all these numbers, and it's apparently grouped by color. So that's why we had only 1 row per color of all the sales with all this data. And here we see those table variables used. So we join to all those table variables. Here we have, otherwise we would have had huge amounts of joins to the same tables multiple times. So that's the idea of these table variables, is to avoid having to do those joins to those other tables multiple times. And then we have a selection on the country region name of the bill region, the ship region, and the salesperson region. Okay. We now know what the query does. Reading the store procedure doesn't give me any idea where the excess of IO might be, but at least I now have an idea what's going on. So one thing you can do is highlight the store procedure and ask for the execution plan only, which is also erroneously called the estimated plan. There's nothing estimated about this plan, but it's a term that's often used. I hate the term. So I call it the execution plan only, because this is the execution plan with no additional information. Now, if you ask the execution plan only for a store procedure, you will see a store procedure here, which is basically a sequence of multiple statements. So you see execution plan here for the first insert into a table variable, then for the second insert, then for the third insert, which is a bigger execution plan because we joined multiple tables there, and then for the actual queries where a lot of stuff is going on. But it's execution plan only, so you don't get all the information you would get from an execution plan plus runtime statistics. You will see how things will run. You can check the estimates, but you cannot see the actuals. Sometimes you can already see something bad going on here, But based on my understanding and knowledge of execution plans, and reading execution plans is for a large part just experience, I don't immediately see anything stick out. So what I'm going to do instead is, we have a store procedure with multiple statements. I don't even know which statement is the problem right now. So what I do is I'm going to enable statistics IO and statistics time and execute the store procedure again. Now we get the results within the messages tab. We get all this information per statement of how much IO was done and how much time was used. And then for the second statement, the IO done and the time used. This is not very readable. The information is there, but it's not very readable. So what I do, click Control A and then Control C to copy. I'm going to start a browser. And I'm going to go to the O Statistics Parser, which is written by Richie Rump and made available to the community. This is a very handy tool, completely free to use. You don't have to specify anything. It's simply open access. You paste the output of statistics IO set statistics time. You click parse, and then you get a nice formatted table with multiple tables, and each of those tables is sortable by each of the columns that you can click. So you can sort it any way you want for each individual statement. So the first statement has a total of 32 logical reads. That's not going to be the excessive IO. So whatever may be wrong with the first statement, whatever methods I can think of to optimize it, will not solve the problem. I'm not going to spend any second on this first statement anymore, because my time is valuable. I need to fix this IO issue. Second statement, 17 logical reads, also not a problem. Third statement, 62 logical reads, again, not a problem. Well, then we only have one statement left, and yeah, there. Look, 163,000 logical reads. That's the excessive IO. Here is the issue. So the entire issue is in the fourth and final statement of the execution plan. The statistics parser output also has a totals table, which in this case is not useful, but in other cases we will use it later in the presentation. But here, when we pinpoint the problem statement, we see the fourth statement is the problem statement. If I sort by logical reads, you will see that the top two producers of logical reads are a work table and a product table. So those are the two tables we're going to focus on. So now I know I need to look at statement number 4, and I need to focus on work table and product table. So let's return to our management studio, and I'm going to enable the execution plan plus runtime statistics, which also erroneously is called actual execution plan. My scroll wheel is really giving me issues right now. Anyway, I'm going to execute it. We get the same results again. We get the same messages again. But now we also get our execution plans. And I already know I need to look at query number 4. One small thing I am going to point out is if you look at query number 3, which has a very low actual IO, you may see that Management Studio thinks it's 57% of the total cost. I talk about this in other presentations as well. I'm not going to spend too much time on it, but I want to highlight this because it is a very clear example of why you should not trust those percentages. If I had looked at those percentages, I would have zoomed in on this execution plan as the most expensive, and I would have expected to do useful work by optimizing this third query. But it's completely wrong. The reason this is marked as 57% is because there are huge misestimates in at least one, probably more execution plans. And this 57% is an estimate even in a so-called actual execution plan. And the estimate is completely wrong. So the 57% means nothing. This one, query number 4, is marked as 41%, but in reality is 99.999% of the work. And I know that the problems I have in this execution plan are focused on product table and on work table. Now, work tables can be used by multiple operators. They can be used by, for instance, hey, I see an exclamation mark here. Exclamation marks are always interesting. That means there's something wrong. And if I hover it, I see that there's a warning. We use tempdb to spill data. That is one situation where I now have a confirmation. Here, a work table is used. So the sort operator spilled data from memory to tempdb to a work table because it ran out of memory. Probably because there was an estimate of one row and reality of 31,167 rows. You see those numbers here. These two sorts, this one and this one, have the same issue. I also see the operator called table spool. Table spool is literally an operator that stores rows in tempdb so that it can later, either on a second execution of the same operator, or in this case, executions of other operators, read those same rows again. So this table spool stores its input so that this table spool and this table spool can produce the same output. The reason this is done is related to the query. In the query, I have some aggregations, but I also have two distinct aggregations. And distinct aggregations means the SQL Server has to remove all duplicates before it can start counting. But if you remove the duplicate product IDs, then your data is no longer valid to count the distinct sales order IDs because those are different rows. So it has to be able to remove rows and then go back to the original data. And that's what this table spool does. It stores the original rows so that here and here in the distinct sort, it can safely remove rows, while here in this upper stream, we still have all the original data available. So this table spool will cause a lot of I/O in tempdb in a work table, but it's related to a user requirement. That's harder to fix. So let's first focus on the product table. I don't see the product table here on the left-hand side of the execution plan, but in the right-hand side, I see here is a clustered index seek on the product table. There's also sales order detail. I'm going to check all the other I/O operators as well, because there might be multiple operators that access the same table, but in this case, it's all the table variables, sales order header, table variable. So this is the only operator that accesses the product table. Let's zoom in again. What I see here is that the number of executions was estimated to be 3.8. The actual number of executions was 38,000. That's a huge misestimate. And this is on the lower side of a nested loops operator. So this means that this nested loops operator executes its lower side once for each row it receives on the upper input. So this upper input has the same numbers as the number of rows. The estimated number of rows is 3.8, which is why we estimate 3.8 executions of this operator, and the actual number was 38,000. If the actual number of rows had been 3.8, this would have been a very valid execution plan choice. With 38,000, this is a terrible execution plan choice and the direct result of all those IOs on the clustered index seek. 80,000 logical reads on a table that I know has just a few hundred or maybe 1,000 pages. This is very inefficient, and this inefficiency is directly caused by this misestimate. So now we have already found the problem statement. We have found one of the two issues in the problem statement, the product table, and we have found what caused it, a misestimate on this number of rows here. Next step is to find out why we had this misestimate. For this, I'm going to go to the right, and then we see all these table variables. And here's the thing with table variables. I'm going to highlight just one now. The problem with table variables is that in almost all cases, their estimated number of rows will always be 1. There are a few exceptions there out of scope for now. Almost always when you use table variables, the estimated number of rows will be 1. In this case, the actual number of rows is slightly more, 8,668. That's just a small difference with 1. That was me being sarcastic, by the way, in case anyone misses it. Here we have, of course, a huge misestimate, and we have the same misestimate here, and this bad estimate then affects the rest. Because we have 1 here, instead of 8,668, this hash match has an estimate of 2 instead of 12,000. This hash match has 1 instead of 12,000. Here we have 1 instead of 2,400. So we see that this way too low estimate ripples through the entire execution plan. All because we use a table variable with a low estimate of just 1. So what are we going to do? we're going to try to fix this low estimate. And the simple way to fix a low estimate caused by a table variable is not to use a table variable. So I'm going to use temporary tables instead. Now, I'm not going to talk about what they are, but I'm going to tell you there are other issues with table variables. So this might not be the golden problem solver. This may cause new problems, but at least we have something to try. So as a first attempt, I'm going to change the sort procedure. I'm not going to fix anything, not even the typos in the comments, not even the bad stuff that I already saw. I want only a single change so that I can check what that single change does. So the only thing I changed was to use temporary tables instead of table variables. I'm going to alter the table. And now let's disable execution plan plus runtime statistics so I get cleaner statistics IO. Going to execute it again. I still have the statistics IO and statistics time on. So I'm going to open a new window, do the same thing. And this is where the grand total comes in handy. So I'm going to scroll all the way down, and now the grand total is 87,000 logical reads versus before we made this change, 163,000. We saved almost 80,000 logical reads. Not bad for just a couple minutes work, right? These 87,000 are still almost all caused by the third statement. And that's because we still have this work table. We did nothing about the work table, so we still have it. We also have the sales order detail at 8,000, and the rest is peanuts. But we already saved a lot. Maybe we already saved enough. Maybe we want to try to do more. If this is enough, if now production runs smoothly, we should stop. We should not optimize just because we can, unless you have time to spare. But if you have no time to spare, then you don't optimize just because you can. You optimize where you have to. Let's assume that we need to do more. So check the execution plan. And if I now execute it again, I'm going to scroll all the way down to the last execution plan immediately because I know this is where the issue is. You will see that some things have changed. For instance, this sort and this sort still have the triangle, but this one here doesn't have it anymore. It has been moved around and it's no longer spilling. So we already solved, as a side effect, we didn't deliberately do it, but as a side effect, we solved one of the spills. We still have two. So if we want to reduce I/O, we can also try to fix that spill. Now, why do we have a spill here? Because the stable spool has a way too low estimate again. 1,500 is the estimated number of rows to go into the sort. 38,000 is the real number. That means that we are going to misestimate how much memory is needed to store the rows that we're going to sort. Why do we still have a bad estimate? I mean, we now have temporary tables. The estimates are perfect. 8 estimated, 8 real. 8,600 estimated, 8,600 real. The problem now is that the estimates go wrong in the joins. So first we join the salesperson to country, which has a filter on the supplied salesperson region. So this only returns the salespersons that work in America. We join that to sales order header. So of all the 31,000 rows in sales order header, only 2,400 work in America, and we estimated that to be 1,895. Okay, close enough. But then we're going to do the same thing for one of the addresses. I don't know by head whether this is the bill address or the ship address. Let's assume it's the bill address. So here we have all the addresses of America. And by matching this, we implicitly filter on sales orders that are billed in America. And we estimate that we go down from 1,895 to just 859. But in reality, we don't lose any data at all. And that makes sense because remember, and I'm going to show the query again, we filter on bill region United States and ship region United States and salesperson region United States. And if you think about your data, it makes sense that if a sale is done by a salesperson who works in the United States region, 99.9% of their sales will be shipped to the United States and built in the United States. These filters are very closely correlated. If we have a larger database, we might have 1 million sales in the United States, and 999,950 of them will be built and shipped to the United States as well. But the estimation model, the cardinality estimation model, has two options to deal with correlation of predicates. It understands completely uncorrelated predicate. That might be it is shipped to the United States and it has the color red. I have no reason to assume that United States has a preference for red products or a dispreference for red products. So if 10% of our sales worldwide is red, then 10% of our sales in the United States will be red, and there will be no correlation. We also have in the newer cardinality estimation model the option to go for partial correlated. That's when there is some correlation between things, but not a full correlation. So let's say, for example, that we have a column that tracks whether our product is painted with an image of the American flag. Americans love to have their flag on lots of their stuff. But not only Americans do that. There are also people outside of America who like to have products with the American flag. And not all Americans always wave their flags. Some just don't want that. So if 10% of our products has the American flag, then probably 60% of our products sold in America has the American flag and 3% outside of America. These are just made up percentages, but to illustrate that there is some correlation, but it's not a full correlation. But in our case, salesperson, ship region, and bill region, that's almost full correlation. Completely full correlation, by the way, would be lives in the sold to Dallas and sold to the United States. If something is shipped in Dallas, it's always shipped in the United States. That's a full correlation. Here we have almost full correlation, and both full and almost full correlations are simply things that the current version of the cardinality estimator does not handle. We cannot in any way tell SQL Server, hey, when you look at this filter and then this filter and then this filter, don't assume that assume that the one filter implies all the rest, that they are correlated. And that's why the estimate goes down from 1,895 to 859 to then 390, while the reality goes first down to 2,436 and then just stays the same. And this bad estimate of 390 is then what causes the also lower estimates later and the spills in the sort. Now we can't fix the cardinality estimator. So I cannot get rid of this bad estimate, but I can isolate it. So what I've done next, I'm going to scroll down. So I left the change with the temporary table because that worked. I'm not going to change that back. If it had not worked, I would have reverted it. But now I also create a new temporary table. And here I only do the join of the sales order header to those three temporary tables and with the three filters. This is now the new fourth query. I hope I didn't damage any ears when I just bumped my hand to the microphone. And then in the actual query, I use that temporary table. So this means that now in the actual query, I can get an estimate that is not based on these estimates, but on what is really in the temporary table. Find the start, highlight it all, execute. We now have our new store procedure. And execute it. And let's first look at the totals again. So once more, I'm going to open a new statistics parser window, parse this stuff, and go to the totals. 85,000 it was. Let's go back to the totals again. 87,000. So we did save a bit. It's not as huge a saving as before, but we did save a bit. And of course, a comparison of statement to statement makes now less sense because the what used to be the fourth statement now is 2 statements. But I'm going to look at the totals here and see that the work table is still there, still does a lot of work. There's some work on temporary tables. But one thing I want to point out is that here we had 8,000 reads in the sales order detail. That has now also been reduced. So that's where we got a rejection. That was not what we were shooting for. We were looking at the work table, but we got this as a nice bonus. But let's look at the execution plan. So in statement number 4, now we have this same bad estimate. I told you I can't fix this estimate. What I can do is isolate it. So we have a bad estimate here, but we store it in a temporary table. And instead of using that bad estimate of 390 for the rest of the work, now do as I want and not as I click. Now the estimate is automatically corrected in the final query, and we still have bad estimates here, but they are not as off anymore. And now they are good enough that if you look, there is no spilling anymore. And that is an invisible I/O saver, because spilling is also writing to work tables. And I always hate the term set statistics I/O. Sometimes I jokingly say the option should be renamed to set statistics I, because it doesn't report output. It only reads. Logical writes are not reported, but those spills caused writes. So we saved invisible. We saved time. That was not our task, but it's nice to do it as a bonus because we don't spill anymore. And we got our logical I/Os even lower effect as a side effect because we got a better join to the sales order detail. Now, at this point, you have to wonder, have I done enough? And in this case, I'm going to assume, yeah, we have done enough. Now, if this still had not been enough, we would have been in a tough spot because, like I said, these multiple count distincts are a direct result of a user requirement. So if you really want to negotiate that, you have to go to the users and talk how important is this user requirement. And before you say that's silly because the users wanted it that way, yeah, they wanted it that way, but they might have asked for that 3 years ago. I have actually had situations where I went to the users and said, this column takes a lot of effort to produce. This is causing the issues. Can we talk about it? And they looked at me, huh? What column? And they went to the architect and said, oh, yeah, we removed that from the dashboard 2 years ago. Didn't we tell you? And then I can just rip out the column and we're done. Sometimes it's a nice to have on their dashboard, and they will tell you, oh, if that is what's causing the problem, then let's remove it from the dashboard. Let's make it something people can ask if they need it, but not put it in their face every time, because most of the time it's not really needed. If you really need to produce all those count distincts, then you will have no option but to either accept these 70,000 logical reads or do a lot of work to come up with something very smart. And there's nothing I could immediately tell you now as the obvious way to fix this, or I would have done this in the example. This is where sometimes you run into the boundaries where you say, if you want this, then it's going to cost you, or we're going to have to do very complex workarounds. Now, you may have noticed, like I said, the comments could have been better. The table variable could have been used somewhere, or temporary table later could have been used in step 3. The table created in the first query was used in the second, but not in the third. Why not? I don't know. Perhaps the assumption that joining all that data, storing it, and then using it, the assumption was that was faster. I'm not even convinced that's true. Perhaps they should not use the temporary tables at all and just write that one big giant query. I don't know. I haven't checked. If we are going to stick with the temporary tables, maybe we can index them for better performance. I didn't look at the indexing now because the temporary tables had a very low I/O number. So that was not where I was going to gain anything. So I see all those possible future improvements. If there's a ticket system, I might just put in a ticket in the backlog, say, if we ever have time, revisit this stored procedure and look at these issues. But right now, there's 5 more tickets waiting for me that are actually hurting people. These observations hurt me because I hate bad code, but they don't hurt the users. They don't hurt my boss who pays me big bucks. So I'm not going to fix that now. Okay, that was a lot of time on the first example. I will admit this was originally a 5-quarter session. I only have 1 hour now, so I'm going to do the second example. I'm not sure I'm going to go through the third example, but I do have some good news for you at the end. That's the cliffhanger, right? Why do I even go there? It's simply the demo. So we have this second example. And again, if there's questions about the first example, ask them now, because in a few minutes, everything will be gone from my brain again that I have said. The second has to do with something called resource semaphore weights. I'm not going to spend a lot of time explaining what they are. The short version is, if you have high resource semaphore weights, that means that the total of all your queries are asking more memory than is available on your system. So they have to wait for memory to become available. And in our case, a senior DBA has used all their tools to find out that the paginated sales report is a query that is invoked from a dashboard that auto refreshes every minute on hundreds of screens throughout the company. That is using a lot of memory, and because the query runs so often, it adds up and the total bogs down our system. So we have this paginated sales report, and if you look at the results, you will just see that there's some data there, obviously sorted by total order quantity. We have 20 rows. Okay, that's all we see right now. Let's go to the store procedure to see what it does. And again, I'm going to use this modify shortcut. Okay, that's nice. 0 comments. Aha, I love it when my coworkers use. The benefit of no comments is that at least I don't have to check whether the comments are still correct. And I don't have weird abbreviation in the comments because there are no comments at all. So apparently there's an optional parameter. I didn't know that. Whoops, that was the wrong shortcut. I was given this code as this is what's causing the issues. I didn't even know there was a parameter. But there is a parameter, page num, and it defaults to 1. Okay. So what do? We have a temporary table called all results. And then we have a CTE here on top. We insert into this all results table. And what we insert there is the aggregated sales data. That was the CTE on top. Let's scroll back. So the aggregated sales data is sales order detail plus sales order header joined, and then grouped by all these columns, and then the sum of the order quantity. Okay, that's the aggregated sales data. And we have a main query where we use that and then join all kinds of other tables. And why are those joins there? Because we have all those dimensions that we want to add, like a product number, a discount percentage, and they're all in those. A data warehouse worker would call it dimension tables, but this is not a data warehouse, so there's just tables. And then we put all that into the all results, and then at the end we just return from all results where row ID is between. Wait, row ID. I don't see a row ID here. That's because it's a identity column. Yeah. It's an identity column, and that's why we have the order by here, so that the rows are the identity column corresponds to that descending total order quantity. Yeah, now it starts to make sense. And then page number, the default page number was 1, so that's 1 times 20 minus 19, that's 1. So the default, which page number 1 gives you a row ID between 1 and 20, the first 20 results. And if you set page number to, for instance, 2, you get rows 21 to 40. So that's a paging mechanism. Now I get it. So we have a dashboard that always shows the first page. And apparently there's somewhere in the user interface an option to go to the rest of the pages. And indeed, when I ask, I get confirmed that this first page is constantly refreshing on the dashboards. And a few times per day, a user will click through to get the rest of the data. I'm going to focus on this page number 1. And not on the rest. But wait, that was the wrong click, sorry. But now I know what the store procedure does, and I know that the problem is memory. So let's go to execute it with the execution plan again. Now with the execution plan, and I see that there are two statements. The second statement is very simple and doesn't really have a huge memory grant. That's all zeros. So the memory grant comes from the first statement, and indeed, click here, you see that there's high numbers here, and especially the desired memory grant is quite high. I'm not going to go through the detailed numbers. The short version is always here. So here the memory grant, the short version is 49 megabyte. That's the problem. On a real system, 49 megabyte would not be a problem. On a real system, the tables would have more data than just 100,000 rows, and this number would be higher. Let's assume that 49 megabyte is a lot for the purpose of this demo. So 49 megabyte is too much. We need to reduce that. And now we have a problem because SQL Server doesn't give us a simple way to find where the memory grant comes from. You might click on operators that you know use memory. That's something you need to know. I know that sorts use memory, that hash match use memory. And there's a few hash matches there, and merge join does not use memory. The scans don't use memory, but it's the hash matches and the sorts in this case. That's simply knowledge. It's like I said, the execution plan reference can help you there to tell you which operators use memory and which don't. Now, if you look at the properties, you will see, for instance, and that depends on your version of SQL Server. This is a quite recent addition, but you will see that there's, sorry, I always hate it when my mouse is suddenly on the wrong screen and wrong screen zooms. So the memory user, but this is not relevant now. This is on older versions you wouldn't have it, on newer versions you would, but it's not relevant because it's the actual memory usage. We have a problem with the memory grant, which is based on the estimates. To get a feel for the estimates, one thing you could do is look at the memory fraction in and input and output, but that's a very complex way. That's something I still haven't figured out yet, something I still on my to-do list, because it should be on the execution plan reference, but it's so tough and complex that I'm keep postponing it. So we do know that the total memory grant, but there is no simple way in the execution plan to look at an operator and say, how much did this operator contribute to that 49 megabytes? There is a not that simple, but still a relatively simple way, and that requires an understanding of the operator. So a sort operator stores its entire input in memory. And if I hover this arrow here, you will see that this entire input has an estimated data size of 12 megabytes. That is an irrelevant number. So the estimated size for the work memory of the sort operator is 12 megabytes. For the hash match, only the top input is stored in memory. So this first hash match has an estimated data size of 240 bytes. This is not the reason we have a 49 megabyte memory grant, because that's just 240 bytes. And of course, SQL Server rounds up to be on the safe side, but this is not going to be 49 megabytes. And by the way, several of these operators might use memory concurrently, so it's not that a single operator does this 49 megabytes. So we can go through all these hash matches and look at the estimated input size to understand whether they are the problem. So we have here 20 kilobytes, we have here 1.2 megabytes, here we have 290 kilobytes, and then we have a hash match aggregate, and for a hash match aggregate, it's the output that is stored in the memory, so we have 3.6 megabytes. So this is the second largest, but the sort is the largest. The sort is the largest, and we need that sort because we want to have all this data sorted in the temporary table so we can pick a single page. But for the dashboard, we're only ever going to need the first 20 rows. And I happen to know that the sort operator can work in a special mode called top n sort. And if n is less than 100, it will use a different memory structure and use far less memory to store only the rows it needs from the current input and just drop rows as new rows come in. So what I want to do is create a special case within the store procedure, one for the generic case where we have a page number, and a special version of the query that is only used for the first page. And I'm going to try this in such a way that I'm going to use the top n sort. So you see here, I have a test if page number is 1. This is the code path we're going to optimize. There's also this else. I didn't even change anything. This is just a copy paste. The only change is that I indented it, and I didn't indent it myself. That's my code formatting tool. But I do have a special case for page number is 1, and here I don't use a temporary table. I just use a simple query, and I directly use the top 20. So SQL Server knows, you're going to sort stuff and then give me the first 20 rows. I hope that now I will get an execution plan with a top 20, a top n sort with n equals 20, which would use far less memory. So I'm going to change the sort procedure. And here's one thing I told you before: you can use the execution plan plus the execution plan only for a store procedure. If I do that now, I've got all the execution plans for all the code paths. You will never have an execution where all of these are done. So this is really not very useful in this case. I am going to execute it. And I know that if I add a page number, I will have the old code path and the same problem as before. But that's just done a few times per day. I'm not going to bother about that. I'm going to bother about that dashboard version that uses page 1 and it runs hundreds of times per day. And I immediately will go to the memory grant, and you see that I did indeed reduce the memory grant. That's the good news. The bad news is that I still see a separate top operator here. And if I scroll to the right, I see a separate sort operator here. Oh, we reduced the memory size because a lot of the joins are now after the sort, and the sort stores all the data but will only return 20 rows because the top only asks for 20 rows, and execution plans are pool based. So after 20 rows, top will simply not ask sort to produce the rest of the results. That's why we have nested loops and clustered index seek for all those dimensions. And that saves all the memory for the other hash match joins. But why don't we get a top n sort? The reason is, I'm going to go back to the query now. We ask for this version of the query, we ask for 20 rows after the join. And the optimizer says, hey, you have this aggregated sales data, but then you're going to join to the product table. Perhaps in the aggregated sales data, the first row is a non-existent product. So I cannot simply do the top after producing this, because then if the first 20 rows happen to have a product that doesn't exist, I lose that here and I have only 90 rows. Or if there's a product with more than one special offer, I suddenly have 21 rows. And you asked for 20 rows. So that's the problem that SQL Server has. If it does a top n sort here, we have 20 rows here. But we might have 21 rows here and then 19 rows here, and the end result will not be guaranteed 20 rows. The problem here is basically a database design issue. We didn't tell the optimizer what we know, because I know that all of these joins will just have one row, always, exactly. But the optimizer doesn't know that because my database design doesn't have all the constraints it should have. Now, let's assume I cannot fix that. So what I do now is I'm going to take a risk. It's sort of a risk because I know that the data is clean, but I'm going to tell, just do the top 20 here. So give me the top 20 sales, and then I don't care whether those joins add or remove rows. So if the data quality is not completely clean, if the data quality is bad, I might actually get 19 or 21 rows back. But as long as I trust the data quality, this should work. Let's execute this and let's check. And now you will see in the execution plan that indeed I do get the top n sort. And now the total memory usage is down to just 14 megabytes. Those 14 megabytes have to do with this hash match here. If we really want to fix that, there are ways, but I'm going to assume for now that 14 megabytes is below the threshold where we are causing problems, that we can stop optimizing now. So that concludes this. And like before, in the final comments, I talk about that there are still issues with this star procedure. It's not clean, nice code. I deliberately set up examples that include bad stuff, because that's what you get when you work in production. We did do the job we were told to do, which was to fix the high resource semaphore weights. Now, with all the dashboards running, the total system memory is enough to satisfy all those memory grants, and we no longer run into issues. Well done. Next job. This is the one I'm not going to fix anymore because I only have 2 minutes left and I can be fast, but not that fast. I told you there's good news. I have started, and the first one is already up, to create YouTube videos, separate YouTube videos for each of these 3 examples. So the first one, the one with the high IOs, is already on my YouTube channel. Somewhere during the next month, I plan to do the high resource semaphore weights, and then the month after that, I will do the erratic query performance. Exact planning can change depending on my mood and other things going on in my life. But if you subscribe to my YouTube channel, you will eventually see this one pop up as well. For now, I'm going to leave you. If there are any questions, Magnus, please read them to me. If you have questions later, mail me or tweet me.
There are no questions in the chat. I don't know if it means you were very clear. That's my assumption. It could also be that execution plans are too hard for people. I don't know.
I just flabbergasted anyone with my speed, and that's also okay. Take your time to process it. That's why I leave my email and my Twitter. I do totally understand, because I've been there in sessions myself where I was completely flabbergasted with all the information, and then 2 hours later it's only, oh, I should have asked that.
Yeah.
So mail me, tweet me. If I don't reply to your mails, that's not me deliberately ignoring you, it's me accidentally ignoring you, because sometimes my mailbox is swamped, sometimes my life is swamped. So if you don't get a reply within, let's say, a week or so, just send me a gentle reminder, and you will definitely get an apology from me for not responding sooner, and hopefully also a response. The response might be, I don't know either, but if I can help you, I will.
I know that's true. I know you reply to emails, and I wish I could say the same for myself, but I normally don't. So, but it's honoring to you that you do. So, thanks for that. Thanks for the presentation, and thanks
Welcome.
for all the things you do for the community, especially around execution plans. There is so many people that you have helped understanding execution plans, which is, I mean, it's complex stuff. So I really appreciate all you do, Hugo.
Complex, but also very useful. That's why I want people to learn this tool. You can, and I hope this presentation gave the audience a feel for how good execution plans are as a tool to help you pinpoint where the problems are, to help you optimize queries, not just by throwing stuff at the wall and seeing what sticks, but first investigating what you should throw and where you should aim. And then you still throw and see what sticks, but you have a higher chance.
And I mean, for this resource semaphore thing, one solution could be to just double the memory in the server. I like fixing the code rather than throwing hardware at the problem, because it's, in the long run, it's going to be less expensive to write good code or better code.
Sometimes throwing hardware is the answer. Not always. My first example contained an example where an issue was caused by a user requirement. There, the answer might be throw more hardware. The problem I have with the throw hardware answer is that, in my experience, most performance issues in SQL Server scale exponentially. And so that means if your customer base expands, if your sales expand, your performance issues grow exponentially. And your hardware budget typically grows linearly with your sales. If you double your sales, you don't suddenly have 4 times the hardware budget.
It's true.
Or the Azure subscription budget, which is the equivalent. Azure services have those handy sliders. It's just a single drag of your mouse and all your performance issues are gone.
Yeah.
And then at the end of the month, all your money is gone as well. So
true.
Microsoft loves to push this idea of, hey, here's this slider and you can easily increase your performance. And yeah, that's great. But only do that when you have so much business that you can afford it, and that is the correct solution, which it sometimes is. If you have an exponentially growing problem, fix the problem and don't try to throw your wallet at the problem, because your wallet is never going to grow exponentially. However, it's going to grow. I hope it's going to grow, but it will never be exponentially.
No, it's true. But I think it's good that you mentioned Azure, because you have some resources or some types of computing mechanisms in Azure where you kind of pay per, tick, or in the mainframe world it's called MIPS, but you basically pay for what you use, and there is no slider. That's when it gets really expensive, if you have exponentially growing.
Yeah, because Microsoft will happily scale
to
address your needs and then charge you for it. If ever there was a time when tuning saves money, it is now, in the time of virtualization and bringing stuff to Azure or AWS or but I always forget Google. What's the name of Google's?
I don't know. I try to
all those services. They all have the same nice thing that they some services automatically scale to fit your needs, which is definitely good. But it does come with a cost, and that's something that the salespeople don't like to tell. But it's good that you bring it up, because tuning your queries, tuning your performance saves money. If you have hardware on premises, then it's either you have the power or you don't. If you have the power, then you don't save by tuning. You might get faster speed, but the direct financial gain related to tuning, that's what you have with service offerings, with all those as a service offerings.
Yeah, that's true. No more questions, but there are tons of comments, all saying well done, perfect presentation, and I agree.
Nice.
You present a number of times before, and I'm impressed every time. There is a lot that fits in your head that doesn't fit in mine.
I'm sure you have lots of stuff in your head that I don't have in mine. I'm just rather specialized.
That might be it. Yeah. I'm off to a meeting. I will leave you to do whatever you do on a Friday afternoon.
Yeah, just boring work, I'm afraid. But thanks for having me. Thanks for giving me this nice break in the day. And good luck with the meeting and with the rest of the SQL Fridays you're organizing.
Yeah, thank you. And for people, if you wonder where the schedule is for SQL Friday, now I have all the confirmations from all the speakers, so it will be published during the weekend. So and I will set up the meetup events so you can all put them in your calendar.
And of course, let's not forget a huge thank you to my audience for being here and paying attention and attending. Thanks.
And you who were here and still are here, please use the knowledge you gain. I know people who they do know how to write good code, or to at least find out where the real bottlenecks are, but they don't take the time to fix their own problems. And it's I'm not going to say they're lazy, they're probably busy, but it's definitely worth trying to do better.
Yeah.
But on the other hand, as a consultant, I get more work if you do not the job. So keep doing what you're doing.
Sometimes it's a trade-off. You can spend too much time trying to create the perfect code first try. You also can try to save too much time and deliver sloppy code. And the fine line is somewhere in between those extremes.
I don't really like the term good enough, but that's what you need to apply, I guess, in the end. So.
In my head, I always want it. After multiple decades in this industry, I still struggle to deliver imperfect code. But it does help that I'm no longer on payroll. I am a consultant. I'm paid by the hour. I can tell myself, does my customer really want to pay my rate to have this fixed? Or am I now not providing the value I charge? But I want to provide the value I charge.
Yeah.
I don't want to do $10 an hour work for my rate, because my rate is a bit more than that. Let's just leave it at that.
Almost 15.
Let's negotiate.
Let's do it. I'm going to stop the recording and stop the meeting first, then we can negotiate on the rate. Okay.